Hello friends, today we are going to learn very interesting unit from your syllabus. That is nothing but plant growth indices. Here absolute growth rate. This is the simplest index of plant growth rate of change in size, which is an increment in size per unit of time. Most commonly, if W is the total dry weight of the plant, then G is the absolute growth rate in the total dry weight. The dimensions and units of the G are mass per unit time. Example is gram per unit. Instantaneously, absolute growth rate G is equal to dW by dt, and its mean value over the interval of T1 and T2 is in bracket W1 minus W2 bracket complete divided by T1 minus T2. The growth curve enables us to work out the rate at which an organism grows. This can be done by estimating the increase in size that takes place during the successive intervals of time. The increases growth increment are then plotted against time. This gives us the organism's absolute growth rate. The absolute growth rate is the change in size per unit of time. Absolute growth is change in size per unit of time, so that if the unit of the time is a small, that root growth rate is a dW divided by dt, where W is the size of the plant and T is the time. Absolute growth rates are often not useful for comparing growth rate under the different experimental or environmental conditions. Environmental conditions, because they are usually proportional to the size of the plant. A better measurement is the specific growth rate, defined as G is equal to dW by W dt. The mean specific growth rate of the time interval T2 to T1 is given by G is equal to in W2 minus in W1 divided by T2 minus T1. Here the specific growth rate can be measured in terms of length, weight or energy, though in practice it is clearly measured in the terms of length or weight. The pattern of growth shown by plant determined by the changes in a specific growth rate in time. So an analysis of the factor that influences the specific growth rate is essential for understanding growth of plant. Friends, I will show you one thing is here. Suppose this is a 5 centimeter square is initial, I will write here initial size of that increases up to this is 10 centimeter square. So 10 final size of the leaf, that is 10 centimeter square minus, so that is equal to the 5. That is equal to 5. So 5 is absolute growth of the plant, that you have to keep in mind. 5 is absolute growth of the plant. Absolute growth we have studied, isn't it? Now relative growth also we can calculate here very well. So what is the absolute growth? That is 5 centimeter square, isn't it? What is initial? Means this size of the leaf, that is 5 centimeter square multiplied by 100. So 100% we have to say that relative growth rate is there. Have you understood this? That you have to keep in mind. Initial size of the leaf, that was 5 centimeter square. In course of time or within a some period, that increased up to 10 centimeter square. 10 minus 5, that is 5 is the absolute relative growth rate we have calculated with the help of another formula. Now crop growth rate RGR. CGR should be there, not RGR. That is relative growth rate. CGR is there. So dry matter accumulation rate per unit of land area is referred as a crop growth rate. Crop growth rate. So crop growth rate is equal to W2 minus W1 divided by SA T1 minus T2 minus T1. Here SA is the soil area, W1, W2 are the crop diameter at the beginning and end of the interval of the T1 and T2 time. Relative growth rate. Already I have said to you how to calculate the relative growth rate. Suppose two examples I will put about you. Initial size of leaf 5 centimeter square, that increased up to 10 centimeter square, isn't it? So 5 is the absolute growth rate. Similar way, suppose another example I will take up. 50 centimeter square is the initial centimeter square leaf size, that increased up to 55. So again here 5 is the absolute growth rate. 1, 2. Now this is 5 is the absolute growth rate of the same of this one. Then what is the relative growth rate? So we know that 5 is the absolute growth rate divided by initial, that is 5, multiplied by 100. So 100% is the relative growth rate of a first leaf. Now second leaf, we know that 5 is absolute growth rate, but 5 is the absolute growth rate divided by 50 centimeter initial multiplied by 100, that is equal to only 10. So second leaf having a relative growth rate is only 10. So this formula you have to compare the things in between the absolute growth rate and relative growth rate. Now leaf area index, very interesting indices of this one. That is, Watson is the name of scientist who actually introduced this in 1947, that he pointed out that the crop growth rate was the product of a leaf area index and the net assimilation rate, this formula. According to him, crop growth rate is equal to LAI into NAR, net assimilation rate, and that is leaf area index. Leaf area index can be calculated leaf area of one of the tiller into number of tillers divided by 10,000. With this, thank you very much.